let's talk about something you are probably using this very second. Your touchscreen. You tap on it, you swipe, you pinch to zoom, and it just works. It honestly feels a little bit like magic, doesn't it? But have you ever actually stopped and wondered what in the world is going on under that solid piece of glass?
I mean, really think about it for a second. It's a solid object. There aren't any buttons or moving parts. So how does it sense your finger with such pinpoint accuracy? Is it pressure? Maybe the heat from your fingertip? What's the secret?
Well, here's the thing that might blow your mind. For pretty much any modern phone, it's not pressure and it's not heat. In fact, you can hover your finger just a tiny bit above the screen, and sometimes it'll still register a touch. The real answer, the secret ingredient, is electricity.
That's right, your touchscreen is basically one giant, incredibly smart electrical sensor. And to really get how it works, we need to talk about this fundamental electrical property called capacitance. So what the heck is capacitance? Well, in the simplest terms, it's just the ability to hold onto an electrical charge, kind of like a tiny, super temporary battery. And believe me, this one concept is the absolute key to the whole puzzle.
And this is where you come in. Your body, being mostly water filled with salts and minerals, is a fantastic conductor of electricity. You are a crucial part of the circuit. The moment your conductive finger gets close to the screen, you actually change its electrical properties.
Okay, so we've established your finger is conductive. Cool. But how does the phone turn that into a precise location on a map, basically? For that, we've got to look under the glass.
Buried just beneath the surface is this incredible microscopic grid of transparent wires. We're talking a layer of wires running horizontally and another layer running vertically. Together, they create this dense coordinate plane that covers your entire screen, totally invisible to you.
Now, these wires aren't just sitting there. They're carrying a constant, tiny electrical charge. Altogether, they generate this stable, invisible energy field across the whole surface. The electric blanket analogy is perfect. It's this uniform field that the phone is constantly monitoring for any little change.
So when your conductive finger gets near this calm little electrical pond, it starts to pull some of that charge towards it. This creates a disturbance, a measurable dip in the field's strength. Your touch is the pebble, and your phone's processor is built to see that ripple.
So here's how that ripple becomes a coordinate in a split second. When you touch the screen, one or more of those horizontal wires and one or more of the vertical wires notice that drop in capacitance. The phone's brain immediately goes, aha, the disturbance is at the intersection of these specific wires, and bam, it pinpoints your exact location. It's just simple geometry happening at lightning speed.
Now, this whole idea of electrical conductivity also explains a super common frustration. Trying to use your phone in the winter while you're wearing gloves. The reason a plastic pen or your regular old winter gloves don't work is because they're what we call insulators. They block the electrical interaction. Your finger can't disturb that electrostatic field because the fabric is in the way. The phone literally cannot see your touch.
But what about those special touchscreen gloves or a stylus? Well, they work because they were designed to solve this exact problem. They have conductive fibers, like carbon or superfine metal threads, woven right into the fingertips. They basically act as a bridge, letting your body's natural electricity pass right through to the screen.
All right, now for the last piece of this puzzle, and honestly, this is the part that I think is just so cool. We've talked about conductors and capacitance, but let's put it all together to see what role you're really playing in all this. First, just a quick refresher on what a capacitor is. It's a basic electronic part. You've got two conductive plates, and in between them you have a non-conductive layer, an insulator. Its whole job is to store up electrical energy in the field between those two plates. So just picture it. Two plates with the separator in the middle. And here it is, the big reveal. When you touch your phone's screen, you become part of the phone's circuitry for a moment. You are actively forming a brand new capacitor.
Isn't that wild? Think about it. You've got the first conductive plate, which is your finger. You've got the second conductive plate, which is that invisible sensor grid in the screen. And what's the insulator sandwiched between them? The glass. Your finger and that grid create a capacitor, and the phone measures that change in its ability to store a charge right at that spot. And all of this, it happens at an almost unbelievable speed. The phone's processor scans the entire grid, checking the capacitance at every single intersection, up to 120 times every single second. That's why it feels so instant, so fluid. The phone is relentlessly looking for that ripple that you create.
So the next time you pick up your phone, just remember this. It's not magic, it's not pressure, it's physics. Every single tap, every swipe is you, using the natural conductivity of your own body to directly mess with an invisible electrical field just under the glass.
And that kind of leads to a final thought, right? This technology feels so intuitive, it's almost like an extension of our own bodies. But underneath all that is just this beautiful, elegant use of physics. It really makes you wonder, what other everyday magic is out there just waiting for a closer look?